Hi, my name is Karamjay Tomsi. My roll number is 20CS30025. I am going to explain about the ceiling fan. First, let's get started with the parts of the ceiling fan. This white thing is the capacitor, and this is the stand, capacitor stand. As we can see, this is a 2 microfarad capacitor, and this is the capacitor stand, and this is the bearing. I removed it. This circular ring we are seeing is called an induction ring. It is made of a pure conductor. It is aluminum most generally, and this is what it looks like when the ceiling fan is open. This is the inner coil, and this is the outer coil. This is the hanging rod, and these are the bearings, which are made out of steel. This is called a laminate, which is a flat which is flat and acts as north and south poles during the working of the fan. These are generally made of electromagnetic materials. The inner coil is also called auxiliary or starting coil, and the outer one is also called a main or a running coil. Each of the inner and outer coils are made out of a single copper wire in such a way that each of the coil is made out of multiple number of turnings. Here the inner coil has about 350 and the outer has 380 turnings. The winding has been done in such a way that each successive coils have different suns of rotation. That is, one is clockwise and the successive one would be anti-clockwise. And here these materials act as insulators to avoid short circuiting inside the fan. Let's get into the working of the ceiling fan. The ceiling fan is a single phase induction motor. That is, it works on passing the single phase AC current. Unlike the three phase induction motor, single phase induction motors are not self-starting, which is why here we use the capacitor to provide the starting torque. The capacitor is connected in such a way that it is in series to the auxiliary coil and combined parallel to the main coil. The circuit is achieved as following. One of the two ends of each coil is connected and combined connected given to the supply. The other two ends are connected through capacitor, and the end corresponding to the main coil is connected to the supply, and thus leading to the required circuit. In this induction motor, this rod and this acts as a stator, which is stationary and held fixed. The induction ring is the rotor, which is made of conductor. As the current is applied, these coils obtain north and south poles, with successive coils having different polarities. These laminates obtain north and these two obtain south. And while moving, the induction ring also produces north and south polarities. Thus, the attraction and repulsion between the north and south poles gives rise to the torque required to rotate. Due to the change in polarities in the coils, since we are using AC circuits, the rotor keeps moving. Explaining the pulse generated due to induced current in the magnetic field, when the aluminum ring moves through the existing magnetic field due to coils, the relative motion of two causes electric current to flow into the current. This is called induced electromagnetic current. Now coming to the repairs of ceiling fan, the mainly uncounted ones are the capacitor failure and the winding damage. When the capacitor got failed, the fan fails to start, and when rotated manually it starts to rotate. This can be overcome by replacing a new capacitor. And in the defects due to the winding, it can be either short circuit due to the improper insulation, which can be easily tested for short circuit by connecting the main body and wire and winding. There can also be a breakage of the circuit, and there can also be several other types of winding repairs, which require changing of the whole wires, and the complete winding should be replaced. With this, I am concluding my session.